holds on to its heat a great deal more, and you'll get a recycling going on. So you can, if you're looking for a less frost vulnerable site, find a large water mass. And if you go back to this, you can see that as we get out, the biggest water mass we have is the Pacific Ocean, as far as we're concerned. And you can see as you get close to the Pacific Ocean, the frost risk is quite low. That looks very similar to your map, doesn't it, David? Here we go, sort of a cold front coming through, strong southerlies coming up the east coast, and then we've got this high pressure system here which follows in. The most dangerous nights, as far as we're concerned, are the ones where basically this front comes through at about 3 o'clock in the afternoon. Because effectively what happens is you get this cold air mass, and the temperature has been caused to drop to about 3 o'clock in the afternoon, and then the sky clears, and by 6 or 7 o'clock in the evening we've got a full-blown radiation event going on. And one of the challenges that our meteorologists have is actually, because we don't have lots of land down here, apart from this sort of bit over here, is actually working out exactly when these fronts are coming through. A 3-hour difference in the time in which the front comes through can have a huge impact on the vulnerability of our vineyards to frost. If this comes through, if this front comes through at 2 o'clock in the morning, it's far less damaging than if it's come through at 3 o'clock the previous afternoon. Our frosts are almost exclusively radiation frosts. The advective component basically has this potential just to drop the temperature, but it's the clearing of the cloud cover that effectively causes the frost to occur. And why is this? Well, basically the Earth radiates at approximately 113 watts per metre squared, and on cloudy nights that is reduced to 10 watts. So the Earth is pumping heat out under cloudy conditions that is being retained by the cloud cover. This happens every day. Okay, it's happening continuously, happening now. It's just that now the sun is generating more heat, and so therefore the temperature is going up. The incoming radiation is greater than this 113. Why do we get frosts in the winter? Because basically the time from sunset to sunrise is longer. The process is going on in the middle of the summer. It's just that in the early morning the sun rises and we start to get radiation coming in, which starts to lift the temperature. It's the length of the night that's important. The other thing that is important, and I'm interested in David's comments about, or was it Greg's comments about climate change influencing the dew point, is that the rate of temperature decline depends on whether you're at or beyond the dew point. The drop in temperature slows once the dew point is reached, and I'll show you some graphs of that in a moment. They say that if you put up one mathematical equation, you send half the audience to sleep. Okay, so, but this is just the process that the New Zealand Meteorological Service goes through to work out the probability of frost. It's one of the techniques that they're using. They're using the dry bulb temperature at 3 o'clock in the afternoon and the dew point temperature at 3 o'clock. And this basically indicates how low the temperature is going to drop at the maximum rate of decline. And then there's a constant in here which changes depending on the day of the month of the year. It's higher for the June to August period than it is on the extremes, and that reflects the changes in the day length. So this is the sort of practice that we've got. They will go out and they will take a measurement here, looking at the temperature at 3 o'clock in the afternoon. They'll get the dew point figure, and you can see here that the temperature basically between there and here is falling quite quickly. That reflects the drop in temperature. When you get to the dew point, it slows down. And depending on where the dew point is, depends on the minimum temperature. Here, the dew point was sufficiently high that the minimum nighttime temperature, which occurs just before dawn, was above zero. On this night, 17th of November 2002, the temperature dropped at about 2 degrees an hour to the dew point, at which point the temperature drop slowed down to ½ degree an hour. Despite that, it still went down to -2 before the sun came up and the radiation started to warm the earth again. So that's the other thing to remember. Minimum temperatures tend to occur just before sunrise. What are the critical temperatures for frost damaging grapes? Now, I've mentioned that the earth is radiating heat. The plants radiate heat as well. As a consequence, tissue temperatures tend to be lower by about 1.5 degrees than air temperatures. When we're talking about what are the critical temperatures, as scientists we tend to talk about tissue temperatures. It's generally accepted that damage occurs when ice crystals are forming in the cells, killing them. And Sonia, I know, is going to talk more about that. Pre-bud break, grapevines can tolerate quite a severe frost. This vineyard here is -40. It's in Michigan. The vines are dormant. The vines basically drain water out of their xylem system over the winter. There are no ice nucleation sites, which are essential for the ice crystals to start forming, and the buds can tolerate very low temperatures. These are American hybrid grapes, by the way, and they tend to be more tolerant of these very low temperatures than Vitis vinifera. And Vitis vinifera probably goes down to about -15 or -20 in the middle of the winter. Do you get those sort of temperatures here? No, we don't either. It's great, isn't it? But as the buds start to develop, the xylem becomes hydraulically connected to the whole plant. You get ice nucleation sites potentially becoming available, and the buds become vulnerable to freezing. They become more vulnerable as they develop. So if they're in a dormant stage, they will go down to -14. As they start to develop, the minimum temperature that they will tolerate tends to go up. And again, one has to remember these are tissue temperatures, not air temperatures. This is looking at 50% of the tissues being killed. This temperature here, 0.6, is if you're expecting no damage at all. The degree to which you can tolerate some of these things depends on your level of nervousness. Some people will be saying, I want no damage. Other people will be saying, I'm actually prepared to take a certain degree of damage. And one of the things about frost is it's what we call a stochastic event. Okay, you're either killed or you're not killed. You can't be half killed. I'm talking about the individual plant parts. Okay, the vine can be damaged, but the individual parts of that vine will either be killed or not killed. And it's a bit like rolling a dice. Okay, you start to roll a dice. How many sixes do you throw? Well, the number of sixes that you throw depends on how quickly you throw the dice, i.e. the minimum temperature that your plant is going to go to, and the length of time that you throw the dice for. And people always say to me when I go and look at a frost event, why was that shoot killed and this one appears to be unaffected? And the truth of the matter is I don't know. It's just one of those things. That shoot that was killed, obviously a nice nucleation event occurred,